Humans once believed Earth was the center of the universe. How arrogant! Later we learned that even the Sun is just a speck on the Orion arm of the Milky Way. That was a harsh reality check. Things worsened after the Kepler mission began searching for exoplanets. Scientists realized our solar system is, aesthetically speaking, a mess. If aliens collected planets like pearls, our solar system would be trashed immediately. Why? Some systems have planets of nearly equal sizes, beautifully aligned like a bracelet. But in our system, some planets are massive, some tiny. It's chaotic. And that uniformity seen in other systems? It's common. Ours is the outlier. So what went wrong? Many scientists believe Jupiter is to blame. It caused massive destruction early in the solar system's history, only stopped by Saturn's timely intervention. This is the story of that cosmic chaos. Look at this chart of discovered exoplanets. X-axis is distance from their star. Y-axis is size in Earth masses. Most planets are in the upper left, big and close to their stars. Only Jupiter fits that cluster. Our other planets are outliers. The most common type is super-Earths, 1 to 10 times Earth's mass, often orbiting very close to their stars. Kepler 11, for example, has 6 planets. 5 are super-Earths. Our system has none. Another example, one system has 7 planets packed within 6% of Mercury's distance from the Sun. Compared to that, our solar system looks broken. Statistically, 7 of our 8 planets are wrong. So what happened? Jupiter. Jupiter is 318 Earths in mass, more than all other planets combined. It's huge. Its great red spot alone can swallow Earth. Similar massive planets have been found in other systems, but most orbit very close to their stars. Scientists call them hot Jupiters. At first, this puzzled scientists. Light gases like hydrogen shouldn't survive near stars, so gas giants were expected to form far from them. The only explanation, they migrated inward after forming. But how? One theory suggests the gas disk around young stars is uneven. Outer gas giants drift inward due to gas pressure differences. This idea laid the groundwork for understanding planetary migration. Now, back to our solar system. In 2005, astronomers at the Nice Observatory proposed the NICE model. Simulations showed that around 4 billion years ago, the 4 gas giants changed orbits, wrecking the solar system's original structure. Earth emerged from that debris. Step 1. Jupiter formed early, at about half its current distance. It started drifting inward and reached the Mars region. Its massive gravity scattered the material that would have formed Mars, leaving it just 10% of Earth's mass. Had that not happened, Mars might have been a second Earth, with a magnetic field, atmosphere, and possibly life. Imagine 2 living planets. If Jupiter had kept moving inward, Earth would have faced 3 fates: becoming its moon, falling into the Sun, or being ejected from the system. But just in time, Saturn arrived. Saturn formed farther out and drifted inward, eventually sinking into a 2-to-1 orbital resonance with Jupiter. This stable lock caused them to reverse direction and drift outward together. On their way out, they encountered Uranus and Neptune, which were moving inward. The encounter flung them outward instead. Some simulations even suggest Uranus and Neptune might have swapped places. This interaction caused their orbits to become elliptical and tilted. The outer solar system turned chaotic. As Uranus and Neptune moved outward, they disrupted a dense region of icy objects, sending many inward. Some of these were captured by Jupiter as Trojan asteroids. Others were flung far into space, forming the Kuiper Belt, home to Pluto. The rest slammed into the inner solar system, causing a massive bombardment. Evidence of this remains in the Moon's craters, formed around 3.9 billion years ago. Jupiter's rampage reshaped the solar system. Mars shrank, the gas giants spread out, and we may have even lost a 3rd ice giant. Meteor storms rained down, scarring every planet. As a result, the inner solar system lost too much mass to form super-Earths. The gas giants, spaced far apart, left the system with a unique structure. But Jupiter wasn't all bad. The bombardment delivered water-rich asteroids to Earth. Without that, Earth might have remained dry and lifeless. Only 10% of Sun-like stars have Jupiter-sized planets, and 90% of those have unstable orbits. That means only 1% of such stars might have a Jupiter like ours, making our solar system truly rare. If the NICE model is accurate, this system is something aliens would envy. Today, Jupiter's orbit holds 2 massive swarms of Trojan asteroids, tens of thousands of them. No other planet has that many. In 1994, humans witnessed Comet Shoemaker-Levy 9 crash into Jupiter. The impact scars were larger than Earth. If that had hit us, civilization would have ended. Such events were once common in the solar system. Jupiter is both majestic and terrifying. Its red spot is a centuries-old storm, and its cloud bands whip at insane speeds. It is protector and destroyer, safeguarding Earth for billions of years. So say thank you to Jupiter.